One of the first pracks we did was involving a pendulum, and we had a length of our pendulum, and we released the pendulum from an angle of less than 15 degrees so that it wouldn't change direction due to the Earth's rotation and smash into the table. We had a few areas we were concerned with: stretching of the string, measuring so the knot didn't turn. The formula we used to work out the period of the pendulum, and hence gravity, was 2 pi on the square root of L on G. The only two things that the pendulum period depends upon are L and the force of gravity, or the acceleration due to gravity on a particular planet. This is constant, and we did 10 swings, if you remember, to make sure that we were more accurate, as if we did the time for each swing and then times that by 10, we would repeat the error 10 times if we were measuring or and having other errors such as timing, reaction time, etc. We had the same person using the pendulum and the same person using the timer or stopwatch to try and minimize error. We did have, as I said before, the error of reaction time, getting the exact time when the pendulum ended or started its swing. We have a parallax error. If we don't read straight onto the pendulum, and we can get some errors working out which way, the time that the pendulum reached a certain time. So the other errors were stretching of the rope, turning of the knot on the top, if there was any wind or air resistance that could also affect the swing. Improvements to the experiment. Well, we worked out 2 second period was a 1 meter pendulum. Increasing the length of the pendulum would give you more time to suit yourself. Getting the same person to use the pendulum. There's many examples of things, but accuracy is mainly taking readings. And you've got reliability, is to repeat your experiment, make sure your results are reliable. The accuracy one is the main one for this experiment, making sure that the timing is accurate as possible. So that's how we worked out, and we rearranged this formula to get gravity. And if I just do it quickly in my head, we get LG was 4 pi squared equals 2 t squared. L 4 pi squared equals t squared g. G would equal L 4 pi squared on t squared. And we worked out using that formula a value for gravity. We also looked at some examples, say on the moon, would a pendulum take longer to swing? Would it have a longer period or a shorter period? And to do that sort of question, you've got that formula, which will not be given to you in the HSC, this formula by the way. And the value for G would be 1/6 that of what it is on Earth. So you could work out and look at that formula and come up with some other solutions. Changing the length of the pendulum and the gravity, as said, are the only two variables that affect the period. So that's the experiment to determine force of gravity on the Earth. There are other ones you could have used, such as dropping an object using Newton's laws, and working out the acceleration, the time taken, and that way finding G by dropping objects. This one, it turns out, was quite successful, and we all did a good job at it. Thanks.